Welcome to another physics class. In our last lesson, we started the topic energy transformation, and we defined the principles of conservation of energy as in an isolated or closed system, the total energy is conserved or remain constant, or energy can neither be created nor destroyed in a closed system during transformation. So today, we want to continue from where we stopped, that is energy transformation in a mechanical system. Now, we are going to have two examples, as I said in the last lesson, examples of mechanical system. We want to consider the energy transformation in these two mechanical systems. One, a falling object from certain height above the ground. Two, a vibrating a suspended simple pendulum ball. That is, we want to look at the energy transformation in these two systems. Now let's take it one after the other. The first one, a falling object. That is, when an object falls from certain height, we want to look at how energy will be transformed that will comply with the principles of conservation of energy. Let's say this is a ball. At this particular point, the height from the horizontal ground, let's call it this point A, and the height, this is the horizontal ground, from here to here, let's call it HA. The first thing we are going to look at, if the ball falls freely to the ground, at this particular point, the total energy here will be equal to potential energy, P. And when it falls freely, let's say this is A, from here to here, let's call it point P. When the ball gets to this point, that is from here to here, let's use another symbol because of this potential energy. So let's call this point Q. When it falls from here to here, and you consider the height that is falling, now the total energy here at point A is potential energy. And when it travels down, the potential energy is totally converted to kinetic energy. That is, at this point, we are going to have kinetic energy. So to obey the law of conservation of energy now, the energy here will be equal to energy here. Therefore, we can now say, apply principle of conservation of energy. That is, P at this particular point will be K at this particular point. That one will now be equal to P at point A will be equal to K at point Q. And the magnitude of the P, as we said in the last lesson, is given as mg is. Mind you now, our H now is HA, which is equal to half mv square. Consider the magnitude of kinetic energy. Now, from here now, to find the velocity of this ball before hitting the ground. So velocity of the ball before hitting the ground. This one will now be equal to, since m will cancel m, so we are going to have GH A will be equal to m has cancelled m, half v square. Therefore, the velocity now, according to the formula, this one will now give us 2g8 will be equal to v square q, that is the velocity at point q. So that this one will now give us v square q will now be equal to 2gha. That is the maximum height from the ground. So the velocity before hitting the ground will now be equal to v now q equal to square root of 2gh, where g is the acceleration due to gravity and h is the height of the object from above the ground level. That is when the object is falling freely to the ground. Let's now look at it in another way. Let's say the ball fall a certain distance like this, fall a certain height at this particular point. If this place is point A, let's call this place point B, and this place point C. Now, when the ball falls to height B, we need to consider find the energy at this particular point. For mark you, as the ball is falling down from A to B, now the potential energy here will have been converted to kinetic energy. So at this point B now, the total energy here now, total energy at this point B will be equal to potential energy plus kinetic energy. That is, we need to calculate the potential energy at B plus the kinetic energy at B. So we can now say at this point A now, already we know that the total energy here is potential energy, which is mgha. Now, total energy at B now, total energy at B, we need to consider, don't forget that the potential energy is about the ground level. So the height here will be from here to here. Let's call this one HB. But the kinetic energy must be energy at motion. So we are going to have, that will be P at B plus KE at B. So that this one will now give us mgHB plus half mv square B. That is the potential energy at P plus kinetic energy at B. We form the total energy at B. Now at C now, the energy at A, which is potential energy, will have been totally converted to kinetic energy. So at C now, it will be equal to KE, which is equal to half mv square C. Now, to take it like this now, we want to calculate the total energy now. The total energy from here to here. Now, the law of conservation of energy must be obeyed. So we can now say that the total energy at A will be equal to total total energy at A must be equal to total energy at B must be equal to total energy at C. Now, as we know, the total energy at A is equal to mgHA. That will be equal to that potential energy, that is PE. This one will be equal to plus equal to the energy here will be PE at B plus KE at B. So to write it like that, that will be mgHA will be equal to mgHB, that is the potential energy at B, plus half mv square B, then equal to half mv square C. Mind you, the other time we consider the energy at this point and the energy at this point. Therefore, we were able to find the velocity of the ball before hitting the ground. Now, we want to find the velocity of the ball at point B now. You can now say to calculate the velocity of the ball at point B. Then we are going to have consider this one, and this one. Therefore, it will be equal to PE at A, that's total energy, equal to PE at the total energy at B. So that will be mgHA. Mind you, we are equating all this one together just to obey the energy transformation, that is from the principle of conservation of energy. So we are going to have mgA equal to PE at this point, mgHB, plus half mvB square. So we want to look for this velocity now. So this one will now give us half mvB square equal to total energy at A, mgHA, minus mgHB. Now, from what is on the board, we are going to have half mvB square, mg common, that will be mg into h minus hb. This equation now, m will cancel m. So we are now left with half vb square equal to g into ha minus hb into bracket. So the vb square will now be equal to g, when we cross multiply that g into bracket h a minus hb. So from there now we can now have the square root of v is equal to b will equal to square root of 2gh into bracket ha minus hb. Don't forget, as I said the other time from the diagram, let's say this is the ball at point A falling down to point B, then to point C at the height here is HA, while the height here is HB. So it means our HA is the height from the ground to the maximum height. That is the point where the ball is falling down. Then HB is from here to here. That is when it falls a certain height. Here now, let's look at example under this one. Work example. Let's take this one as example 1. The ball of mass 6 kg is released from a height of 30 meters. Calculate the 1. Potential energy. 2. Velocity before impact or hitting the ground. Now let's solve it. From the question, mass of the ball is given M as 6 kg. The height above the ground level H is given as 30 meters. Then, mind you, under this question, G is equal to 10 meters per second squared. Now, G is given as 10 meters per second squared. Now, from there now, to answer the first question, 1, P, that will be using the formula mgh. So from there, we are going to have 6 multiplied by 10 multiplied by 30. And from this one, 6 multiplied by 10, that will be 60 multiplied by 30. And that one, this one will give us 1,800 joule. That is the P, that is the potential energy, 800 joule. Question 2, velocity before impact or before hitting the ground. Now, velocity before hitting the ground, the ball is released from this height. When the ball is released, the potential energy will be transformed to kinetic energy. That is what we are considering, energy transformation in a mechanical system. If that is the case, and the question says we should calculate the velocity, therefore we are going to have, we've calculated the potential energy as 1,800. Then you know that the magnitude of Ke is equal to half mv squared. Therefore, you can now say P be equal to half mv squared. We need the value of P, which is velocity. So that one, this one will now give us 2P will equal to mv. So V squared now will equal to 2P over m. Therefore, V now will be equal to square root of 2. Our PE, according to what we have calculated here, is 1,800. That multiplied by 1,800. Mass is given as 6. So this one will now give us, so 2 multiplied by 18, that is 36. So this one will now give us 3,600 over 6, all into square root. So V now will be equal to, that's square root of 600. And the final answer for velocity before hitting the ground will be equal to 24.495 meter per second. 24.495. That's the velocity before impact or before hitting the ground. That is for example 1. Let's take this one as example 2. A stone of mass 5 kg is dropped from a height of 30 meters above the ground. Calculate the 1. Potential energy before it begins to fall. 2. PE when it falls 80 meters above the ground. Then 3. Velocity when it falls 80 meters above the ground. Now, to solve this question, solution. According to the question, let's draw it and see. Let's say this is the stone. Then the height above the ground is 30 meters. So this is the stone, and the height from the above the ground is 30 meters. Now the first question says to calculate the potential energy, which will be the total energy. Potential energy will be equal to mgh. That's question number 1. And from there, our m is given as 5, 10, and height is 30. So from there now, this one will now give us 1,500 joule. That is for question number 1. For question 2, when it's for 18 meters above the ground, let's say this is how the stone is for. So 18 meters above the, let's say this is the ground, 18 meters above the ground. This one will be 18 meters above the ground. So the first question says, under that one says you calculate the PE. So PE at 18 meters using the same formula. That one will now give us, that's question 2, mgh. Then mass is the same, 5 multiplied by 10, but the height now is different, 18 meters above the ground. That is 18 multiplied by 18. So when we multiply this one together, this one will be 50 multiplied by 18. So this one will give us 900 joule. That is the PE when it's for 18 meters above the ground. The question now says, what will be the velocity when it's for 18 meters above the ground? Now, the next thing is to calculate, to find the velocity, that is the kinetic energy from here to here. That one will now give us the, from there we'll be able to calculate the velocity. So we can now say that Ke at 18 meters above the ground will give us half mv square. That is 18 meters above the ground. So if that is the case now, the total energy at this particular point now, total energy at this point, that is 18 meters above the ground. So total energy at 18 meters above the ground will now give us the PE at that particular point, T at 18 meters, will give us PE at 18 plus KE at 18. So that one will now give us 900 plus half mv squared. Now, from there now, since the stone starts from this place, we can now say the total energy at this point will be equal to total energy at this point. So total energy at 30 will be equal to total energy at 18 meters above the ground. So we now say apply principle of conservation of energy. That is, energy PE at 30 meters will be equal to total energy at 18 meters. So at 30, that's 1,500 is equal to PE at this point, 900, then plus KE at that particular point. So from there now, we can now say KE at 18 meters will be equal to 1,500 minus 900. So KE at 18 meters will be equal to 600 joule. Therefore, if that is the case, we can now say that since we need velocity and k is half mv squared, then is equal to 600. So this one will now give us mv squared will be equal to 600 over 2. So mv squared, 600 multiplied by 2. So this is 1 over 2. Cross multiply, that's multiplied by 2. So v squared now will now give us 600, that is 12,200 over what the mass of the stone according to the question, 5. So v squared now will equal to 1,200 over 5. So that will be all into scale. It will be square root of 240, and the square root of 240 will give us 15.49. 15.49 meter per second. 15.49 meter per second. That is the velocity at 18 meter above the ground. Let's take this one as example 3. A stone of mass 60 grams was released from top of the tower 50 meter tall. Calculate the 1. Potential energy of the stone just before it was released. 2. Potential kinetic energy of the stone after it has fallen through vertical distance, vertical height of 20 meters. 3. Velocity of the stone just before it hits the ground. Now, from this one now, question number 1, let's draw it and see it again. Let's say this is the tower. The height of the tower, according to the question, is 50 meters. A stone was released from this place, and the mass of this stone, M, is equal to 60 grams. Because of the other unit, which is meter, and G must be given also as 10 meters per second square. So we need to convert this one also to kg. That's 60 divided by 1,000. And the answer will give us what? Is 0.06 kg. Now, one question says we should calculate the PE of this stone just before it was released. So PE, that question number 1, will be equal to mgh. And our m is 0.06 multiplied by 10 multiplied by 50. So this one will now give us, that is 0.06 multiplied by 500. So the answer will be 30 joule. That's 30 joule. Now, that is the energy when the ball is about to release from that height. Question number 2 says we should calculate the PE when this stone is fall through a vertical height of 20 meters. So let's say from here to here is 20 meters. So then from here to here now will be equal to 30. Don't forget, the difference between this question and the last one, the question number 2, example 2, is that the other one is fall above 18 meters above the ground. But this one is falling through vertical height now from the top. So to calculate this, that will be 50 minus 20 equal to 30 meters. Now, PE at when it fall 20 meter now, 2 PE when it fall 20 meter. That one will now give us PE at 30 meter from here to here. But PE deal with gravity and high it should be high from the horizontal ground. And the height from here to here, according to this calculation, 50 minus 20 is 30 meter. So that one PE at 30 meter will now give us the same mgh. But mark you now, our height now is not 20 but 30 from the ground. So that one, this one will now give us 4.06 multiplied by 10, then multiplied by 30. So that one will have 0.06 multiplied by 300. And this one will now give us, this one is 18 joule. That is 18 joule. Now, this question number 2 is 2 in 1. We need to calculate the kinetic energy also at that particular point. Now, to calculate the kinetic energy now, that is KE at the same height at 20 meter. KE at 20 meter. Mind you now, we were not given velocity, but since we know that, don't forget our topic, energy transformation. KE will be equal to PE. That's to show that mechanical energy, conservation of law of mechanical energy, that potential energy can be converted to kinetic and kinetic to potential. So it has happened here now. So, but KE at 20 equal to PE at 20 now. But mark you, since this one is KE, it deals with energy or motion. So the height we are going to use now is 20. Why? Because kinetic energy is energy at motion. Potential energy is energy at rest. So here, potential energy at rest is 30 meters. But here now, since we are dealing with kinetic energy, energy of motion, it must fall. And the height that this stone fall is 20. So that one will be equal to mg is 20. So this one will now give us 0.06 multiplied by 10 multiplied by 20. So this one will now give us 0.06 multiplied by 200. And this one, the KE at that particular point now, when it falls 20 meters, equal to 12 joule. 12 joule. And if you want to know, maybe the calculation is correct or wrong, it must comply with principle of conservation of energy or principle of conservation of mechanical energy. Look at it, that energy must be the same, remain constant. Look at now, let's say we want to calculate the total energy at this point now. Then it must be equal to energy at the initial point. This is 30. Look at the total energy now, 18 plus 12 equal to 30. It means the calculation is correct. Let's say now the total energy we arrive at here is not equal to 30, then something wrong. So that is energy. So if the question asks you now to calculate the total energy at this particular point, now it must be equal to total energy from the initial state. That is the kinetic energy when it falls 20 meters at the vertical height. Now, velocity of the ball just before it hits the ground. So, the first example, we consider, let's say this is the ball before it hits the ground. You consider this point and this point. And to apply energy transformation also, the energy here will be equal to energy here. So from there I can now say velocity. That question 3, velocity just before hitting the ground. That one will equal to velocity at the initial state, the energy at the initial state equal to energy at this point. That will be P at 50 meter will be equal to Ke at this particular point. So, and we need velocity. So that one will now give us, since we calculated the P at that point as 30 joule, so it will be equal to 30 is equal to half mv square. So from here now, you can now say 30 multiplied by 2 is equal to mv square. And from there, this one will be 60 is equal to mv square. V square now equal to 60 divided by our m there is 0.06. So v square now be equal to square root of is equal to square root of 1000. V now finally will be equal to 31.62 meter per second. That's the velocity just before it hit the ground. That's for example 3. Let's take this one as example 4. A stone of mass 2 kg is released from a height of 12 meters. Calculate the 1. P before it was released. 2. Height with which the velocity will be 5 meters per second. G is equal to 10 meters. The first question, 1. As usual, let's draw it and see how let's say the height now is 12 meters and the stone is located at this point 2 kg. This is the stone. Now to calculate the PE now, that question number 1, PE at that particular time, that's mgh, that is total energy that as the stone is being moved, it must be equal to energy at any point. So the mass is given as 2 kg, that's 2 multiplied by 10 multiplied by 12. So this one will now give us 240 joule. 2 multiplied by 10 multiplied by 12 will give us 240 joule. Question number 2 says at what height will the velocity be 5 meters per second? Here now, velocity is given at 5 meters per second. But the first thing we need to do, we need to calculate the energy at that particular point also. Let's say it falls to this point. So let's say this is the stone. It means the question says we need to calculate the height with which the velocity will be equal to this one. So taking it from the ground, let's say this place will be, we don't know the value at which it is being fall. So that will be the diagram. If this place is A and it falls to this point, the height now, when the velocity is 5 meters, will be hb. So we need to find the value of hb now. That is the height when the velocity is 5 meters per second. So to calculate this one, then we need to calculate the total energy here. Now say total energy at B. That will be the PE at this particular point, PE at B plus KE at B. So that one will now give us mghb now plus half mv square. So from this one now, our mgh will be equal to, the mass is 2 that will be multiplied by 10. We don't know H, that's HB that we want to calculate, plus half multiplied by 2 multiplied by V squared. Mind you, V is given, velocity at 5 meters per second. So V is given, that is 2 multiplied by 5 squared. So this one will now give us 20 HB will be equal to 2 will cancel to, plus 25. 5 square will be 25. So if that is the case now, we need HB. Then already we know that we will follow the energy transformation. The energy here will be equal to energy here. We can now say applying energy, apply conservation of energy, conservation of energy. As our energy is transforming, the energy will be the same at any particular point. It means PE, when it is at 12 meters, will be equal to total energy when it is at point B. So, and that one will now give us the P at this particular point is 240. That one will now be equal to 20 HB. That is the height. The question has to calculate when the velocity is 5 meters per second. So plus 25. So from there now we can now say 240 minus 25 is equal to 20 HB. That is the height when the velocity is 5 meters per second. 215 is equal to 20 multiplied by HB. So without wasting time, the height now, which we call HB, will be equal to 215 over 20. So the height when the velocity is 5 meters per second now will be equal to 10.75 meters. That's the height when the velocity is 5 meters per second. And to this point, we are going to stop the lesson for today. As I promised in the beginning, we want to look at two mechanical systems, but we are able to look at one now together with the calculation aspect of it. In our next class now, we are going to take that of a vibrating simple pendulum bulb. We are going to look at the energy transformation in that system also. So if you are just joining us for today, for you to understand this topic better, please try as much as possible to watch our last video on energy transformation. And again, you need to like, share, and subscribe. So when I upload a new video like this, you'll be able to get the notification. Thank you.